everybody. Welcome. We're going to, my name is Lynn Strickland. I'm with the Canadian Home Builders Association with the Net Zero Housing team. And we have our renovators. We'll be going through and introducing each one of our speakers and panelists as we move through. We're going to wait about a minute to get everybody in the room, and then we'll start with our air tightness and air barriers as part of our Renovating for High Performance webinar series. So we'll just hang tight for a few seconds. Just as a note for those joining the room, if you have automatic AI note takers, those will just be removed. We have our admin that just will be removing those. So as they come in, they'll just be bumped out. Sometimes those note takers start without our knowledge, but those are ones, but you'll be getting the recording, access to the recording afterwards. Okay. So welcome again. Hope everybody in the room. It's a very rainy day. We're finally getting the rain that we need, but we're getting it all at once. So I hope everybody's house is airtight and waterproof. But we're going to kick off with this Renovator series. But first, we're going to get into a little bit of housekeeping. So if you've been on these webinars, the questions that you want for the panelists go into the Q&A. If you have any technical issues, they go into the chat, or if you have, just commentary on that side. But if you have a question that you want to have answered, we're only monitoring the Q&A, so please put them in there. And again, as always, be thoughtful and considerate in the chat. We will have a Survey Monkey at the end of this webinar, so please fill that out right away so that we can capture your thoughts. As a note, if you do want to change your screen view, if you look at the top right of your view, that is where you can click that icon and you can, manage your view from there. And then we'll be making sure that the recording is available following the webinar. So this webinar series is one of 5 that we have been working with Building Knowledge Canada over the past year, and we've selected the top 5 critical topics for when you are renovating towards net zero. So what that includes is high performance renovations all the way to full net zero renovations. It's part of a 4-year Natural Resources Canada funded project called Towards Cost-Effective Net Zero Energy Ready Residential Renovations. This is through Natural Resources Canada, but we've been collaborating with Building Knowledge Canada from the beginning. We're now in the 4th year. We're wrapping up in March 2026. And part of this has been working with municipalities as well as our home builders associations across Canada, our Net Zero Reno Advisory Group, and of course, our project teams who you'll get to hear from today. When we get into the last parts, we want to share our lessons learned. So this webinar series is one of the ways that we are sharing the information, not only that we've taken from communicating and hearing from homeowners, municipalities, and project teams, but also from the demonstrated results that our project teams have seen and the successes that they've had in the field. So you can sign up for all 5, and we'll have this QR code again at the end so that you can get access to that link. So the webinar project team has been a dedicated team over the past year. We've got Andy Oding, Toby Smith, and Kimberly Cobb from Building Knowledge Canada. We have Gord Cook here from Building Knowledge as well as our subject matter expert. And we also have Lori Howe, who's been our administrator on this Towards Net Zero Reno project, and Brendan Fraser, who has been spearheading the case study development as our technical analyst. I'm Lynn Strickland, and I've been the project lead on this since 2022. So today's webinar is focused on air tightness. This is this all-encompassing but really critical aspect that is very challenging and yet so worthwhile to address when we're undertaking renovations. So to that, we are going to provide this mix of the what and the why. Gord will get into why this is so important, some of the building science implications, not only on the structure, but also on the occupant as well. Then we're also going to hear from our project teams. So we have Mark Tritton, Felipe Falou, and we have Stefan Magneron. Stefan Magneron has been the EA for both these projects. So we are going to hear from the project teams themselves how this has mapped out on the ground in the field. So when we get to looking at what this initiative has been about, we have been working with 13 municipalities across Canada, working to scale deep energy retrofits. The targets were 100 to 150 deep energy retrofits representing different climate zones from across Canada. And what we actually were able to achieve was 350 residential units that we're attempting to achieve towards net zero results. So you can see the span of the number of units. These may be single family homes, which accounts for almost 40% of our enrollments. A third were multi-unit residential, and the rest were attached housing, whether it was row or town housing or duplex housing. So you can see the spread across Canada of our representation. So we're getting a lot of feedback and a lot of information about something that may work in one jurisdiction that works fantastically in another, and sometimes where it doesn't. So when we look at our existing housing stock of over 15 million homes in Canada, there is a lot of work. There will never be a case where we do not need to maintain and upgrade our existing housing stock. That is a continuum. And when we look at the economic impacts, these are 2024 statistics. So when we look at these statistics, homeowners are investing. Close to $108 billion was invested by Canadians in home renovations and repair combined. Some of these are due to, whether you faced a hailstorm, and other ones are because they're in the middle of a completely aesthetic upgrade. What we are looking at is that a lot of the drivers of major renovations are non-energy driven, but how we achieve thermal comfort, better indoor air quality, better control and use of your space is through the process of moving towards net zero. It's the craftsmanship, it's the building science, it's the attention to detail, and that is giving homeowners what they want that is primarily non-energy driven. But by performing it in that process and with that due diligence, they're getting both the energy reductions, the GHG reductions, which is obviously a global benefit, and non-energy benefits that matter directly to the homeowner and drive that change. When you are a renovator trying to balance all of these, what we're looking at is that through these projects, we have seen that there are projects that work completely towards they map to net zero ready or net zero, and it's an all-in-one. Many of our projects require a phased approach. So our renovators are trying, and our renovator teams are trying to balance all of these expectations. One of the key messages that we've heard over the past 4 years is that homeowners are looking for a trusted source of information. So through the training, we train our members, we train our renovators, our energy advisors, what it takes, what are the unintended consequences, what are the opportunities, so that then we can leverage that roadmap of understanding what can be achieved with the house. And if it needs to be phased, that we're always cognizant of the building science implications and the impact to the occupant, such as air tightness and ventilation. And we have a topic on ventilation coming up in December. So these are the thoughts where we protect the asset, we protect the occupant, and we build that capacity within our renovation industry to provide these type of high performance upgrades. So we're going to do a few polls so that the team can see who's in the room, where you're from. So Kimberly, I'm going to turn it over to you to bring up the polls. I'm just going to give a few minutes to see where you're from. It says hosts and panelists cannot vote. So on that, while we're just waiting for that, I am from Ottawa. Mark Tritton is from the Lanark area in Ontario, and Felipe is from Quebec, and Stefan is also from Ontario on this particular webinar. You'll hear from other renovators from across Canada as we move into the other webinars. Okay, let's see where everybody is coming in from. Okay, so we have got representation from all. That's fantastic. That is wonderful. That is fantastic. We have 190 in the room and a really nice, at least a voice from each corner of Canada. Where you have one more poll, Kimberly? All right. So we're looking at, oh, we have builders. So builder or renovator, let us make sure a lot of our documentation we find industry-wide does put builder and renovator together. So please be aware, we do recognize you as renovators. So if you are a renovator, please put in the builder. And a lot of our renovators are also custom design build as well. All right, let's see. Okay, great. We've got, so architects and interior designers are at the front end of this. We are really eager to hear your voice. Manufacturers, great. We have some academic, HVAC. We've got a site supervisor. Love the teams coming in. And then in the chat, great. We're going to hear from some voices on there. Now, Kimberly, do we have one more poll or is?
No, just the two.
Okay, fantastic. All right. So with that, I'm closing off my introduction, and we are really proud today to have Gord Cook as our subject matter expert. So when we talk about homeowners wanting to look for a trusted source, our industry looks to Gord as our trusted source. So Gord has a vast amount of experience going back from, with indoor air quality, as well as communicating the value of what we are doing with high performance renovations. So with that, we're going to just hang in there and we're just going to get Gord up on the screen. So one of the things that was interesting for me coming on to this project is it was a number of years ago that I got to meet Gord when we were both working on CMHC projects with the residential indoor air quality training program. So that's going back a bit, but it's nice to be back together again on that. All right, Gord, thanks.
Thanks, Lynn. And boy, aren't those numbers compelling? Just as you said, 15 million houses, a nice little start, 350 on this project. That gives a really good start of a data set that says we can get this done. I'm just so impressed by the work CHBA has done on this and the commitment. It's just obviously amazing opportunity. I'm glad to see there's almost 200 people on the call, over 400 registered, because we can really make a difference with this kind of information. So thank you all for joining. And I'll take the next 40 minutes or so and just give you a sense of our first topic. As Lynn said, this is a series of, and hopefully you'll listen in on all. And you would say, why did you pick air tightness first? Well, you're going to see why. It has some really compelling portions to it in terms of making sure that unintended consequences isn't reached. And so these 5 points, if you will, 6 points, why air tightness is so important specifically on that path, that roadmap, if you will, to net zero. We'll talk a little bit about how you benchmark and measure so you can be more successful. We'll do a little bit on tips for understanding air tightness test results, some air barrier strategies, and a little sample of some important details that you'll want to learn more about. As Lynn said, we will have time for questions, but basically at the end, if there's a compelling, really urgent question, put it in the Q&A, and Toby will know, Toby Smith will know to call on me and say, Gord, hey, could you answer that particular question? So let's get started. And so let's start with that question of why airtight. And there's 9 reasons on the screen. I'm going to go in more depth on most of those, but fundamentally understanding that air tightness was put into codes and as part of this program in order for it to limit flow of moisture into cool cavities. It also allows for the improvement of comfort control from a draft and so on. Oddly, sometimes People think that air tightness is bad from an air quality perspective, but I'm going to show you that in fact it improves the opportunity for air quality control. Some pretty obvious ones: reduction of noise, reduction of odor and smoke control in attached dwellings. You may not may not know that it's totally impact on the peak load requirements, and in a net zero reno project, one of the things that you inevitably end up doing is wanting to improve the efficiency of the mechanical equipment. And one of the nice parts is if you've done good air tightness work on the building, you can reduce the size of that equipment, and that helps mitigate the cost of putting in more efficient equipment. Some other obvious ones: eliminating the entry of pests. And you would say, well, of course, it must be about energy efficiency. It could be because it's part of that net zero energy program. The last one, to my mind, is actually the most important, which is meeting expectations of homeowners for ever higher performance houses. So we want to chat about that as well. The pictures on the right are kind of alluding to some of the things we're going to chat about. And so important to understand that Canada embarked on the leading building science research that was taken around the world. That research started in the 1970s. People came from around the world to watch what we were doing. And one of the most important aspects of that research was that as they increased levels of insulation in houses, they started to realize they were having moisture issues. And you can kind of imagine it there, the picture on the right, that warm, moist air rising into an attic that is getting colder. Why is it getting colder? Because on the left, you're adding more insulation. The more insulation you add, the colder the attic gets. And any warm, moist air that gets into the attic is going to condense on the first hard surface, in this case, the roof sheathing. And that was the fundamental link between, oops, if we're going to insulate, we have to make them more airtight. Because of the reduced drying potential and because of the colder surfaces, we don't want hidden moisture problems. There was lots of work done on this. In fact, lots of failures on this. The early attempts to make existing houses more energy efficient, a program called the CHIP program, the Canadian Home Insulation Program. Very quickly, they realized that if insulation went into attics without first air sealing, we ended up with problems. And insulation and air tightness kind of got a bad name. We don't want to let that happen. So understanding that link is critically important to you and I. Fundamentally, this has nothing to do with energy efficiency. It has to do with maintaining the durability of the building, the durability and resistance of the building. All of these projects, these three projects here, the problems you're seeing are due to houses not being tight enough. The one on the right was sort of a poster child. This picture's been around for decades, and the anomaly here was people looked at this and said, oh, they're making houses too tight. See these problems we're having? No, it was exactly the opposite. It was air leakage through that electrical outlet past the R20 insulation that was causing condensation. If you stick your finger in a wall in Canada, the more the insulation, the more chance there is of condensation if you have holes in that building enclosure. So warm, moist air leaking into cold cavities results in damage, keeping that in mind. And indeed, that research, that experience in the 70s and 80s led to code changes. Specifically in 1995, this brand new section, 925.3, was added to the code, air barrier systems. And notice the underlies bits. The rationale for this was not in an energy section. It was to prevent excessive moisture. Moisture and condensation. The bottom two, they're preventing moisture condensation on the room side during winter and ensuring comfort conditions for the occupants, minimizing drafts. Notice the last one, it's not highlighted there, but minimize the ingress of soil gases. So the tighter you make the building, safer, healthier, more durable. And in this case, this was enacted in the code. It has been there since 1995. Let me say that another way. New houses today, anything built in the last 30 years is required to be air sealed in accordance with 925.3. So indeed, we want to do that to older houses as well. In fact, many of the net zero rental projects you're going to be working on maybe have been built in the last 30 years, and you're going to have an opportunity to say, gee, I wonder how well they did on that building code requirement. And again, just highlighting the importance of keeping moisture out of walls. And when you add insulation, you have changed the drying potential. And we've had lots of programs over the years that did in fact give us piecemeal incentives, the various iterations of various programs. And we noted that if we don't couple that with air tightness efforts, that we are going to have problems. In this case, though, we're going to have to think about it from a process perspective, what we would call house as a system. Everything impacts everything else. That's a great old term, house as a system. That's a 35 to 40-year-old term that was coined by the researchers back in the day, Jim White and various others, of on being careful that as you make changes to a house, everything impacts everything else. And it will have an impact on comfort, air quality, fresh air, and so on. One of the things we hear is, well, leaky houses have better air quality. If we're going to make houses tight, we might end up with a poor air quality. And again, nothing could be further from the truth. When you think about when you want fresh air and where you'd like to get that fresh air from, we didn't used to get fresh air through electrical outlets. We used to get fresh air by opening windows. And when we stopped opening windows because of noise, dust, security, and energy costs in the 80s and 90s, we started to have air quality problems. We blamed them on houses getting tighter, but that wasn't the case. In fact, a very important study done by CMHC in the 80s found that the leakiest houses actually had the worst air quality. The leakiest houses had the worst air quality. And it kind of makes sense, right? When you think about air flowing through your walls, through old building materials, that wouldn't give us good air quality. So understanding the relationship, and we are going to talk about ventilation in another one of these webinars later on, but don't be discouraged or don't be thinking that you don't want to make a house because of air quality, because in fact, we can show you the air quality actually gets better. So when it's done properly, of course, is where we're at. And then in terms of the energy efficiency, if we think about gigajoules, we all know that's the new term, right? Gigajoules is the normalization of cubic meters of gas and kilowatt hours of electricity into one metric, gigajoules of energy. And if we took a typical new house, this is showing at an air change rate, and I'll describe what air changes is in a minute for those who don't know, but a typical code build house is expected to have an air change rate of 3 to 3.5, for example. That house in total, when you think about its air leakage, foundation, heat loss, windows, walls, and so on, if it had 116 gigajoules of energy. But in this case, if we simply took that house down to 1.5 air changes per hour, the new gigajoules would be 104. In other words, we're able to show a really dramatic reduction, 12 gigajoules of energy. That's like putting 12 to 15 solar panels on the roof. And when I make the building more airtight, it ends up being the most cost-effective energy measure, and it has the ability to reduce peak load demand, not only overall energy use, but peak load demand by as much as 50%. And that really is important, again, in this net zero rental world, because it really facilitates the application of heat pumps. And I'll come back to that in just a minute. So here is this peak load idea. Now, this one isn't showing 50%, but what it is showing, an older house, one of the case studies that was done of the 350 of 8 air changes per hour, has a heat loss of 54,000, so let's say 55,000 BTUs. You see that orange bar there, or gold bar, I guess, on the left of the graph. And when we get it down to lower levels of air tightness, we're able to reduce that peak load requirement. What does it end up there, Lynn? Actually, my screen is blocked by, frankly, your image. If I got it down to say 1 air change, what's the new heat loss? You're on mute, Lynn. Oh, she may be locked out.
40,000.
Toby, are you there?
Sorry, yeah, going
40,000
into
at
there
180.
for the 40,000, which is
Yes, 40,000
significant.
BTUs. That's basically a furnace size, right? From 54,000 down to 40,000. That's 1.5 tons smaller. That means when you go to put a heat pump in the house, it can be 1.5 tons smaller. There's some dollar savings to that. And then just the practicality of how big a heat pump can I possibly buy? So that's a really powerful example of air tightness at work. To the synergies of, right, house as a system is really pretty powerful. So important to get that done. And then in terms of cost effectiveness, again, the value of the work that's being done by these project teams in the first 350, they've started to realize it is indeed the most cost effective. And so I'm going to highlight to you down near the bottom of the graph. Notice along the bottom, it's the percentage of energy savings. On the graph, the y-axis is the cost in order to do that. And you're showing from a base down at the very bottom of the drawing 4.5 air changes. If I simply get it to 1.5 air changes per hour, I've seen about a 12% improvement in energy savings at a cost of under $20,000, let's say 15,000. So but that sounds like a lot for air tightness. Oh, there's other things involved, right? In taking apart houses to make them airtight. If you contrasted that, say that if you move up the curve, starting at 4.5 air changes and adding, in this case, the orange dotted line is by adding R10 of insulation to the exterior of a building. So insulated sheathing, recladding the building, that might have a cost as much as $55,000. But again, you're only seeing that 12% savings. See what we're doing there? We're saying that air tightness from 4.5 down to 1.5 has the same energy savings as putting 2 inches of foam to the outside of an old house. And the air tightness only cost you, let's say, a quarter or a third of what it would cost. So it in fact becomes the most cost effective. The other lines are showing combined effects of adding R20 or R30 to those walls. So just a really interesting idea. And remind yourself, I don't want to be insulating walls until I've made it airtight anyway. So the left-hand side there, tighter is always better. It reduces energy use, heat loss, risk, and so on. So make sure that air tightness is the first thing that you want to consider in your project work. And then think about, well, we've all had this experience with a wildfire smoke of last few years. And in those circumstances, what would be the ideal scenario? Well, of course, the ideal scenario would be an incredibly tight house so the wood smoke doesn't get in, and say add back a ventilation system with a HEPA filter in it. That would make the house more resilient during those events. So it helps control sound, odors, and air pollutions. It has huge advantages to what we're trying to do. In terms of the, if I move, yep, go ahead.
Sorry, can I interrupt just for 1 second?
Yep.
Pretty relevant question from Jacob here. Another one from Pierre, but I know we got a slide pertaining to that coming up. Jacob's just wondering, when you say air tightness is cheaper than insulation, is that adding in the additional ventilation? So I think
good point.
That you don't have as much ventilation if you make the house more airtight. Also, so yeah, that's part A. What ACH would you say is absolutely necessary to add mechanical ventilation?
Really good question, and I will answer that straight up. And we're going to, as I say, have another webinar on that. So first of all, I don't know on that particular graph whether ventilation was part of that 15,000, but here's what I will say. Adding ventilation into a house in a renovation situation is in the order of $2,000 to $3,000. Depending on the market you're in, it might be a little bit more than that. So imagine, okay, I got to add $2,000 to $3,000 to ventilation. But I wouldn't blame the ventilation on the air tightness alone. To your question, how tight should a house be? I'd go the other way. When do people want fresh air in their homes? And the answer is all the time. Existing houses do not have proper ventilation. It's a standalone item on itself. All houses need the capacity for continuous mechanical ventilation. Why? Because we stopped opening windows. Stop blaming ventilation on the fact that we're making houses tight. We used to ventilate our houses with windows. It was right in the codes in the 1940s. All houses shall have windows, and the encouragement was, literature was written saying to people, leave your windows open, but for essentially all the time. All houses need ventilation. If you're not doing it naturally by opening windows and you're expecting it to come through electrical outlets, that's a false basis, a false comparison. So all houses need provisions for mechanical ventilation. Sure, we could link it to a net zero reno, but it should be done in all houses. Hopefully that adds. So you're not going to get from me what I need, what you want in terms of air tightness, because I can tell you my brother's house is 14 air changes per hour. He's got a ventilation problem because he never opens his windows. He needs a ventilation system, even though he's 14 air changes in terms of air tightness. So that said, codes would start to say around 3 air changes, it's a must. So I'm going to answer your question, but I'm going to say to you, leave that out of your mindset, that ventilation's a requirement anyway, it's not linked to air tightness. Hopefully I've said that enough times and we can go back at it again with questions later. So thank you for that. Next, we want to think about, let's get on to exactly how does air leakage work. And you'll all have a sense that air moves in and out of buildings by wind, a stack effect, which is warm air rising, and mechanical effects, things like bathroom fans, range hoods, dryers, and so on. And what's important to understand is back in the day, we thought about managing those pressures. Managing those pressures. Could we make a house just tight enough that would allow wind to come through and so on? We learned pretty quickly that wasn't reliable. And because the pressures vary from season to season and from house to house and day to day, and it wasn't practical to try to manage those forces, it was way more practical to manage the holes and then to simply ventilate a house by either opening windows as you needed them or putting in a mechanical ventilation and or both. And what is important to understand in a Canadian context is stack effect is the most persistent, consistent airflow mechanism. Therefore, the taller the building, the greater the air leakage, the colder the weather, the greater the air leakage. And again, it varies dramatically. So this is just important to understand. If you're going to air seal, knowing that stack effect is the most important, you would say, well, geez, then I definitely want to air seal at the top of the building, and I definitely want to air seal at the bottom of the building. That's a good hint as we move towards how are we going to do this in a cost-effective way. And how important is it to net zeros? We're going to say you really can't go ahead and insulate a house, add insulation without air tightness, and you'll never meet the performance objectives of energy efficiency without doing air tightness. And it does involve all components, all trades. It's a very holistic thing. That makes it a challenge, and you need to talk to everyone and get them on board. And one of the things we need to get them on board with is tight is good. That you're still going to hear from every trade contractor, well, you don't want to make it too tight, you'd have to add ventilation. And you're going to be so confident in saying, actually, all houses need ventilation. Why? Because we're not opening windows. See where I'm going with this? We're all going to have to be on the same page. So you're going to need a strategy. It is a system, and it means you're going to need a detailed plan for each area of the home as you're working on it during that net zero ready at Reno. And it does require continuity, both physically and throughout the process of doing this. And again, remind you that it's the most cost-effective energy savings. So your question is how tight? Well, there you go. The early research, which I would say in Canada was the R2000 program, smack dab in the middle there at the right, set the number at 1.5. Fundamentally 1.5 to ensure that there was not going to be significant leakage into the cavities to cause condensation. The Passive House program set it tighter than that. Why? Because the Passive House program advocates for far higher levels of insulation. And the more insulation, the tighter you needs to be. Programs like Energy Star took a little bit of a softer approach, 2.5 air changes. I mentioned to you code kind of notionally is 2.5 to 3.5. The net zero Reno target is 1.5 air changes per hour. That's good old Canadian research. You're following the footsteps of 50 years worth of research that says 1.5 is where you would like to be. And then you would say, and we mentioned it before, that, but I need ventilation. Yes. So come to the Ventilation and IAQ webinar, and you will find that this also is useful from a radon perspective. If you want to reduce radon elements in your houses or risk in your houses, you'd make the houses more airtight. And I mentioned that study, that CMHC study, that said the leakier houses had worse air quality in general, not because they were leaky necessarily, but just in general. Old houses don't necessarily have good air quality. So we are going to talk about that in future sessions. For the moment, suspend your thoughts on ventilation. Remind yourself that air tightness is good. We'll resolve any air quality, lingering air quality doubts you have later on this. And you can imagine, we're going to advocate that you benchmark the air tightness on every project. It helps identify the challenges. It helps you identify potential damage and risks. It helps you pinpoint where the work's going to need to be done. Most importantly, to my mind, is it helps visualize the waste and what can be done about it. If you're trying to prove to people that this would be a good project to add energy savings, turns out that the fear of loss is more motivating than the expectations of savings. The minute you put a blower door in a house and have homeowners or designers or trade contractors feel the air leakage spots, they intuitively go, oh, we definitely want to fix that. Because so more than anything, the reason you're going to benchmark is because it helps you sell the concept of building a net zero reno. So use it for its full value as part of the education process and helping people make good decisions. Most of you hopefully have a sense of air tightness testing. I'll just remind you though, it's a big fan that goes in the front door there, you see in the picture, a fan that draws air from the house. You open up the front door, put this canvas in, set up. Stefan's going to tell you in about 20 minutes, put the fan in the front door, start exhausting air out, and you create a pressure of what's called 50 Pascal of pressure. And you, what is that? 50 Pascal is roughly equal to a 30-kilometer-an-hour wind on all sides of the house at one time. Now that's clearly an exaggerated condition. The reason we use it is because it's really demonstrative. It exaggerates the leakage points so that you can find them. And it allows you to compare results when you use the same pressure on a house before or after, or one house to another. It gives you a really good basis for comparison. And it does allow you, because I can take those numbers and turn them through a series of algorithms, turn them into how does the house leak on a normal day? That is, the house doesn't leak this way every day, but we have algorithms work that's been done over the last 50 years that would say, here's how we translate that into what that would mean from an energy perspective. So really useful to do that. I'm showing you the testing that's done, and you'll notice there in the bottom axes, from 0 Pascal all the way up to 70 Pascal. So typically you're testing at 7 or 8 different points. You're creating what's called a leakage analysis, a leakage curve for the house that allows us to predict where that energy, where those air leaks might be and characterize the nature of those air leakage spots. So 7 or 8 points that allows us to characterize. And here's the actual results. This particular house there on the left, airflow at 50 Pascal, 4.1 air changes. Not too loose, not too tight. We'd like to get that too, if you remember, 1.5. The next little box, leakage areas, the software is able to say, if I put all the holes into one spot, how big would the hole be? And in the Canadian context, the US uses a different calculation, but in the Canadian context, this is a hole that's 158 square inches. What's that? That's like a 14 by 14 hole left in the house. And again, you can imagine if you say to a homeowner, yeah, you have a doggy door open year round, would you like me to look at that and fix it? So the bottom little box there shows you some of the more technical information that helps you characterize the nature of holes in the building. So let me show you that quickly as to what that might mean. So for example, when you extrapolate that line, it shows you what the pressure would be, or sorry, the airflow would be. Notice that red arrow butts up against the 10 Pascal line. It turns out the sort of average normal pressure in a house, when you think about stack pressures, remember we talked about warm air rising, is about 10 Pascal of pressure on average over the course of the winter. And this is showing at 10 Pascal, the house on the left leaks at the rate of 260 cubic feet per minute. The one at the right leaks at 400 cubic feet per minute because the holes in that house are different. The slope of the line, if you're looking at the bottom bullets, the slope of the line helps predict or identify the types of holes, big and round holes versus small and thin holes. The one you're seeing on the left is small, thin holes that don't leak as much at lower pressures. The one on the right is showing bigger, rounder holes that keep the air leakage characteristics. So it gives you a little clue in your energy rater, Stefan, and others will help you with this to say, oh, we're looking for bigger holes or small holes. It just gives you a little sense of what might be happening. Here's another technique. It's called zonal or series pressure. If you want to know where the leaks are at, remember I mentioned there on the left that we're taking the house up to a negative pressure of -50. What we're doing here is showing a pressure tap. Jerry there on the right is putting a little pressure probe up into the attic. And if the attic was perfectly sealed from the house, you'd be measuring 50 Pascals of pressure there too. If it's lower than 50 Pascals, and you see on this slide, 37, 36.9, it's actually indicating that there's a significant leak between the house and the attic, or you might do it between the house and the crawl space. Toby, was there a question that you had?
There was, yeah. Pierre had a question related to this. how much of the air leakage can be attributed to the attic?
And there you have it. This, isn't that kind of nice? You could say, I can do a characteristic. There's actually a way to do a formal calculation on this with a little greater technique, but it wouldn't surprise you. The reason this client, and this was a house this winter, they had attic rain, moisture coming out of the attic, dripping out of a ductwork and so on. And we were able to prove literally in 20 minutes that in fact was air leakage to the attic. And it pointed them to, you don't need more attic vents. You don't need more insulation in the attic. You don't need more soffit vents. What you need to do is pull up the insulation, air seal the attic floor. That's going to simultaneously stop your moisture problem. It was really a manifestation, right, of what we've been talking about. If there's warm, moist air leaking into a cold attic, you're going to have condensation. So that one simple measurement is called zonal or series pressure, and every energy advisor should know how to do that. If they don't, they can look it up in their manual and do this literally in 20 minutes. So it's kind of an interesting technique. And then we'll move on to that was the process of how we do air tightness testing. Let's just turn our attention in the last few slides to think about, so when we say air sealing, what do we mean? Well, what we're talking about is a series of tapes, caulks, foams of the primary air barrier. That is, what is the material that's in general stopping air from getting into walls? Is it the drywall? Is it the polyethylene? Is it the sheathing on the outside? Is it the cladding? And it turns out it's never the cladding. Brick's not airtight. Vinyl siding's not airtight. So we're looking to determine what is the primary air barrier and then just completing it by caulking, seal, taping. This should be encouraging to you. It means you don't have to wrap the entire house. You don't need to go up into an attic and spread out poly over the entire attic. You simply need to identify the material that's already resisting airflow and find the holes in it and seal them up. So let's have a little thought of that. We can do interior air barriers. Drywall is a fine air barrier. Plaster and lath is a fine air barrier. Poly vapor barriers are good air barriers. Spray foam itself or poured concrete in a basement, not block walls, but poured concrete walls. Or if I'm recladding a building anyway, well, OSB or plywood, foam sheathing on the outside could be your air barrier, gypsum. Again, poured concrete, or the water resistant barrier, the Tyveks of the world, even the roof membrane. All of these materials could be the primary barrier, and all you need to do is seal them. Remember that house, about 14 square inch hole? I just need to put caulks, tapes, sealants, and seal up those 14 by 14 hole, and in order to make that house more airtight. So there's a great example, right, of a plumbing stack put in a house. That would be a 1950s house, didn't really understand air leakage. That's an older, that's probably not a 1950s, it's an ABS pipe, so it wouldn't be the 1950s. But basically in the attic, you're pulling back the insulation, team of short guys up there, find and seal the holes, and then add back that insulation. You have to find the right material for the right job. This happens to be a good place for spray foam. You might use a gasket there as well. That would be fine. So different products. And you'd have to think, well, if it's a chimney, if it's a hot chimney, you'd have to use a fire-rated caulking or let's say a metal shroud. So you have to have the appropriate materials. There's a can light, a pot light that leaks really well. Here's a fire-rated top hat for that pot light. You can order them online. It's fire rated, put it over top, or on the right-hand side, you could build a box over it. So that would work really well. So just looking for in each location, what's my best strategy, finding compatible materials. It's messy work. I've done it in 3 different attics in my lifespan, my own house twice, 2 different houses that I own, my son's house. It's messy work. It's a couple of, if you're doing it yourself, it's a couple of weekends of work, or in the case of a net zero Reno, you're going to be up there for an afternoon with a couple of folks. Some would say, could I just pull back all the insulation, take it out and spray down an inch of foam? And the answer would be, of course, that would be an interesting strategy, and then add insulation back on top. Even in the last month, there on the right-hand side, this is a new product that's just available in the last month or 2 that gives this new wide spray foam or caulking. Look what they're sealing. They're sealing the top plate of the intersecting wall. There it is on the left. It's always been a big area of leakage. These little micro thin lines, but they were really hard to seal, caulk, tape, and so on. And here's a new product that gives you this wide fan. I just think it's kind of cool that people are coming along with products that makes this easier to do. And then you'll see a lot of older houses, the classic wartime story-and-a-half houses with knee walls. So we need to think about the detailing of that. Nothing more important than a blower door test here. In some cases, you actually turn the blower door fan around and maybe even use theatrical smoke. So we're positively pressurizing the house. Somebody's in the attic while we're doing that. And we'll start to see this down, for example, on the right-hand side, you'll see this this big air leakage coming out from the bottom of that knee wall. And you go, oh, geez, I gotta foam that. And again, there's products for that. You could call somebody with a spray foam truck, or you could say, hey, there's these canned, two component foams that I can buy as a kit and do my own application. So just lots of places to look for air sealing. And then in the foundation, typically the rim joist or header is the most critical. How do we know there's air leaks there? Well, because the spider webs are there. And if there's spider webs, that means there is air leakage. So spray in place foam is ideal. As I mentioned to you, a concrete wall is already airtight. A block wall is not. So you'd have to find an application of a block wall. And you'd say, what can I use there? There's various fluid applied membranes that could go on a block wall, or maybe you're going to use a foam board insulation that could be taped, and that could be your air barrier on top of a block wall. So those are the kinds of details you're looking for. And then it gets a little, tedious, but you're thinking about using the drywall, caulking and so on of electrical outlets behind baseboards or along the baseboards, and whether I take the baseboards off and seal in behind, or whether I'm using the baseboards themselves as the basis for it. Toby, a question?
Yeah, quick question came in from Scott. Said, did you say no spray foam on inside of block walls? Why not?
Oh, no, I didn't say that. My apologies. I said block walls themselves are not airtight, and you'd have to find a strategy. And one strategy, assuming there's no moisture issues in that block wall, by all means, spray foam. Now, the foam would then have to be covered, right, from a fire perspective, but sheet foam or spray foam on a block wall is a fine strategy, assuming there's no moisture problems. So you'd want to address the moisture problems first. That'll be a focus, I'm sure, of future webinars. So we'll just watch our timing here. We're almost finished. Here's a classic example of air leakage. This is a tub that was 25 years old. They're trying to decide in a reno, should we pull the tub? I don't know. We kind of like it. It's a jacuzzi. Now, if there's a tub on an exterior wall, pull the tub, because what you'll notice in here is that for the last 30 years, the location of the cold air return underneath the box of the tub was directly connected to the outside, because there was never an air barrier in behind the tub. So plan to pull the tubs to seal behind anything on those exterior walls, little boxed in framing components. Those are often big air leaks. You could say, would I find that during a blower door test? And the answer is yes. You would find that during a blower door test. You'd feel air leak coming to that return air, and you'd say, we're pulling the tub. There is also an opportunity, the technology called AeroBare or AeroSeal. This technology works really well in houses that are undergoing a major renovation. That is, if the flooring is out, the cabinets are out. It could be a bit sticky, and you'd have to cover all horizontal surfaces. But if it's a major renovation with flooring out, this is an interesting technology. I would say it's a game-changing technology that finds the holes during a blower door test. It's basically pressurizing the house, employing this sealant that fogs the house, and the sealant seals around exterior wall penetrations and so on. So an interesting technology. It's a proprietary technology, so I won't give it too much emphasis other than have a look at that particular technology. Or in fact, we could do it from the outside. So sheet membranes, insulated sheathing. In fact, I'll go this far. If you're recladding a building, you must put foam on that wall. I don't care if you're doing net zero reno or not. Anybody on this call from this day forward, if you're doing a recladding of a building, you must put foam on it, and or weather resistant barriers or mineral wools with water resistant barriers. And let's make sure we're making the building airtight from the outside. Absolutely critical. And understanding that we need to integrate airtightness into the design of the project from the outset. Understanding how important airtightness is, understanding the earlier the better, and looking for that approach. Am I doing interior? Am I doing exterior? What materials or systems am I going to use? Measure it pre-reno. It helps you sell the project anyway. And that old phrase, you can't expect what you don't inspect. And look for that optimization. Everybody remember the number, put it in the chat, please. What level of air tightness are you looking for? How many air changes per hour? 50 pascals. Just remind yourself that should be your goal. How will you know whether it's achievable? Measure first, see where you're at. And we would say, put these kinds of elements in writing. Make sure that you're in your scopes of work, you're telling contractor what needs to get done from their perspective. Mr. and Mrs. Plumber, Mr. and Mrs. HVAC contractor, you're going to be responsible for the holes you make. And Lynn, I don't know if you want to speak to this. We're about done in terms of my element here, but it actually fits nicely right into the roadmap of that net zero renovation of where does this fit into, is thinking about looking at phase one. Let's do that pre-inspection and testing in phase two. Let's work it through the process, put it into your scopes of work. Lynn, you found this roadmap to be really helpful to the project so far. Did you want to comment quickly before we move on?
Yeah, I think a key part is the intentionality, looking at that air tightness as a critical metric to monitor, because one of the worst things that we've experienced is projects that come to us that go, I didn't think about that until it was too late. And now here we are. And that's kind of the path has gone off towards net zero, and it'll just run parallel, but a little bit off. So it's really trying to protect the work that you're investing, the money and the time that you're investing. This has to be part of the design.
I love that, the intention, right? Just writing that in. That's pretty fascinating. And you do have these strategies in the design, is to identify. We always talk about drawing the red dotted line to identify what is the air barrier. On the ceiling, it's the poly and the drywall, but on the outside, we're using the foam, perhaps, that we're renovating, or the mineral wool with a WRB, water resistant barrier. That's going to be our air barrier. Looking for those locations that might be tough, behind the tub, behind a fireplace, for example. What about the house to garage connection? Or do we hire a handyman to do the air sealing? All of these things that we want to plan into, intentionally plan our strategies as we go through this. And then during the construction, I love that term, air boss, who is going to be the leader on this? And should we do, for example, a mid-construction air tightness test to see how we're doing? So these are all things that help us with this. I love that. Install site signage, that you're responsible for the holes in the air barrier, put it into the scopes of work. And so making sure you're on track. The later, as Lynn's suggesting, the later in the process, the more expensive repairs are going to be. So think about it early, get going on it. And in terms of the air tightness results, making sure you're asking your energy advisor for any insights, thinking about air change of power, where you want to get to, that 1.5 is your big goal, and how big those leaks are, how many there are, thinking about and using the results to help you identify where those leaks are. The theatrical smoke in renovation tends to be pretty useful. And make sure you phone the local fire department before you do it, because you're going to get phone calls at house on fire, but it can be a very useful way to look for the air tightness. And this is just a visualization. This was an old CMHC piece. I think it used to show the size of holes, that estimated leakage area that I spoke about, that 14 by 14 square hole. And in thinking about an older home, maybe it's a 21 square inch hole, 16 inch square hole. In a round hole. Net zero, we're down around, an 8-inch diameter, net zero reno. And so it's really demonstrative to help your customers understand that I'm going to get rid of the doggy door, and I'm going to have left just a small little hole, and then we're going to add ventilation back to your project, and you're going to be in good shape. And then, of course, the final air test, making sure you've improved things. And sometimes you have to do a little touch up near the end. I always like to say, you don't fail air tests. It just means you got a little more effort, right? Nobody fails an air test. You just keep working until you can get there in almost hours. And as Lynn said, be intentional and learn from the experience of others. It's really about a path of continual improvement. I'm running short of time. My apologies, Lynn. But thinking about the details that are problem areas, there's lots of literature that would point to this. Really, it's about the air tightness test, though. I'm showing this slide really so that just a memory tool for you when you get a copy of the slides. But the air tightness test is where you really want to think about finding these locations, finding those difficult spots. And that allows me to introduce you to a fellow who's done literally thousands of air tightness tests, both in new and reno. Stefan, I know you get really excited by air leakage. You and I geek out on this kind of stuff. I don't know if you use an ostrich feather or a smoke pencil, but I know you're really an expert at finding these, and you're going to work with your team, Felipe and Mark here, to help us understand how you manage air tightness on these projects.
Thanks, Gord. I really appreciate the intro and setting up the scene for the importance of air tightness and why we work together as a team to achieve the results that we've been achieving. And that notion of teamwork is super important. We don't do things independently to achieve great results. And I've been fortunate enough to work with Felipe and Mark on several projects. So it's definitely a relationship that continues on, and we both learn from each other to be able to achieve greater results on future projects.
I think I might have just screwed you up. My apologies. I might have just screwed you up. Let me.
You want me to share my screen then, Lynn?
You go ahead.
No, that's okay.
You're back up. You go ahead and share. Take control. My apologies. I screwed that up. Yes,
that's okay. I'm requesting control again.
Yes. There you go. Thank you.
So yes, the teamwork. As much as I, as the qualified net zero energy advisor, have a lot of experience on the theory of air tightness and also on the practicality of doing thousands of blower door tests and finding air leaks with different methodologies, whether it's my hand or smoke pencils or theatrical smoke machines or infrared camera. I really lean on the experience of my clients and builders who are actually doing the work and actually coming up with or identifying issues and things like that. So I really appreciate this teamwork and being part of that team as early in the process as possible. So let me make sure that I can flip screens here, which so far I can't.
There you go.
There we go. Okay. So the first project is Felipe's project in Quebec, the Sucrerie retrofit. And I'll let Felipe set the scene, so to speak, of this project, and then I'll add bits and pieces along the way. So Felipe, if you will.
Absolutely. Well, thank you all for having me. It's a pleasure to be here. It's always nice sharing experiences. I think that I mean it's common knowledge that everybody should have, and I think as a builder, I just love sharing those in hopes that other people get influenced too, right? So this project, it's a very special project. So it's slated to be Quebec's first future net zero ready. And I say future because we're still waiting on the install of solar panels. Right now it's net zero ready, and it's going to be, fully net zero afterwards. Quebec is sort of like just announced a nice subsidy program for solar panels. So we're kind of waiting on that until the owner installs it. But this project's it's essentially a retirement home about an hour and a half north of Montreal, Quebec, in a city called Saint-Agathe-des-Monts. It was an old barn that was converted into a house in the 1960s, and then now retrofitted last year. So we sat down with the owner, and actually he didn't have the property in mind. We came from the get-go. The owner came to me and was like, I want to do a net zero project. I want a net zero house, but I don't have a property for it. So we chose this property to be the right project. And I think that speaks a lot, because I mean, we can retrofit every house, but some houses are maybe easier to retrofit than others, depending on the scope of the project. And this house was really chosen with a project in mind to really make it the most cost effective and the simplest approach, because if you're taking a simple approach, you will achieve great results if you're simplifying pretty much all those details. So I guess this project really, the main concepts behind it was was two renovation approaches. First of all, it was called a chainsaw retrofit, where we kind of cut the eaves off to kind of go achieve a monopoly framed house, so that we can have a very easy and defined continuous air barrier. So that was the first concept that we approached this renovation with. And the second one was a Larson truss, which was exterior insulation. So mind you, this project was supposed to be really just from the exterior. Of course, as we went through, there were some changes to the interior. We found, the drywall was smelly. There was mouse poop everywhere, so we kind of had to do it from the interior too. But the goal initially was to just do it from the exterior. Also, orientation of the house was kind of chosen so that we would have a very big south-facing roof line. So that's why this house for us was perfect, because it was kind of ready to have that retrofit and good, strong foundations, good structure.
So this was the perfect retrofit project, Felipe, for the Towards Net Zero Reno initiative. It checked off all the boxes for the perfect candidate. We had the chosen perfect house for all those reasons that you just mentioned, the perfect renovator, qualified net zero renovator, the perfect client, and if I might say, the perfect net zero energy advisor.
Completely agree. It's not every project that we get lucky, but on this one, we really were able to kind of control all these variables. But yeah, so that's why we were able to really go the full way with this project. So like I said, the client wanted to achieve net zero from the get-go. It was a retirement home for them, so it's a project where we also wanted to have like good access for them, so that everything is accessible on the main floor. No big sills, so where they could really go away with wheelchairs, pretty much everything around. And the client also was part of a movement called Net Zero Churches, so he's very involved in that, and always was wanted to kind of have sort of this proof of concept to show that it is doable, especially in here in Quebec, where we're kind of a bit behind compared to the rest of Canada. We have kind of different challenges. Yes, we have a clean grid, but we don't just do it for the cleanliness and the carbon that we're saving. We're doing this for all the other benefits that Gord kind of mentioned before, that comes with a high-performant house and air tightness, right? So, Stefan, do you want to go a bit more into the upgrades that we kind of did?
Absolutely. So here's the list of upgrades that we used to achieve this net zero ready at this moment with the future full net zero. And the top of this list of the upgrades included is achieving that 0.74 ACH. Now, what it doesn't say here is that it started off with about 9 ACH, if I recall correctly, and we didn't list it on here, but it was about 9 ACH for that old barn farmhouse. And we were able to get down to 0.74 ACH. In fact, Gord mentioned the idea of doing mid-construction air tightness tests. We ended up doing, I think, 2, Felipe, correct me if I'm wrong. And the first one, and we'll have a photo of it a little bit later in a subsequent slide, but with this exterior approach with the chainsaw retrofit, we were able to test the house as early in the process as possible. So once the windows were in with the window bucks and the house wrapped, we were able to come in and test it, and it actually tested at about 0.4 ACH. So it really speaks to the idea that that approach, if relevant for the particular project, is a very successful way of achieving great air tightness relatively easily. So if you're already doing walls, taking off the siding, redoing the roof, chopping off the overhangs in that chainsaw retrofit approach and wrapping it actually simplifies the process. And I would say that it would end up being on the lower end of the cost side of things to achieve that level of air tightness. And then after that, the Larson trusses, so the roof would be re-roofed to achieve that R60. The walls had a Larson truss on the outside, and we'll show you more details about that. The foundation had interior air tightness details implemented in it. The windows, because of the deep wall, window bucks were installed in that double wall modified Larson truss setup, and it all worked out. And I would say that Felipe, as the air boss, not only implementing it, but also supervising. It shows that not only do you need great details, great installation, but also great supervision. So that
Yeah,
all
definitely. We didn't get there by any mistake. And I think having an air boss is not, it's not just a good thing. I think it's ultimately necessary. If there's not one person that is responsible for it and kind of watching it at every step, it's gonna get some places are gonna get lost through the cracks for sure. So even me as the owner of the business, I'd say I'm not the hands-on guy. I'm not the guy doing the work on the job site, but I do make sure that I am the air boss, and I make sure that I'm always there with a roll of tape and or a caulking gun and trying to get those spots and making sure that everything is sealed.
Oh, I went too far. So here are sort of the energy results, just to touch on that really briefly. So everything that you saw on the previous slide contributed to the 74% energy reduction. And because it was already an all-electric home in Quebec, the GHG reductions were equal to that. No renewables yet, but perhaps in the next year or so, we'll get some of that on and achieve full net zero. The carbon balance is interesting here because of all the new material that went into the project, including the siding and the insulation and the windows. It ended up a very little impact, mostly because of all the carbon sequestering cellulose that was used as part of the Larsen Truss and over-roofing strategy. So that's why you see some really, really low numbers from that perspective.
And for us here in Quebec, as I was mentioning, like our operational carbon is already very low because we have this clean grid. So when we're looking at net zero, right, we always have to think, well, what's the real net zero we want to achieve, I think, as a nation? And I think it's a net zero carbon, not necessarily energy. So looking at the whole carbon equation of this build here in Quebec, the embodied carbon is always very important here. So it has a huge impact. Hence why we always try to steer away from foam or high carbon carbon intensive materials such as foam products or foam byproducts. So really on this project, we kind of on the main house, not the extensions, we were able to keep it at no foam products, which was something that we really wanted to achieve. Of course, spray foam has its place and setting, and we tried to avoid it as much as possible, but sometimes it's the right material for the right job.
I think we kind of addressed all of this, so I want to really go to the details, Felipe, if you don't mind me switching over to here. And to answer, I think there was a question in the chat there from Jason Christlock about how thick of a wall is required for this R47 wall. Well, it kind of shows in these details here. There was interior insulation using rock wool that was installed.
2x6.
In the 2x6 wall, and then a 8-inch Larsen truss or modified Larsen truss. The details are slightly different to what you see in these initial architectural drawings, because with that really proud foundation that was existing, the gussets for a typical Larsen truss was not needed, and so the exterior double wall just sat bared on the existing foundation wall with a little bit of capping required to level it out. But what I really want to point to everyone's attention here is the level of detail in these plans that also show that this red line of the primary air barrier to identify the strategy with which the air tightness would be achieved. So that's one thing that I encourage everyone in the design phase to actually do that red line test where you draw a line through the trickiest cross section of the plans. And if you have to lift your pen up at any point and connect it somewhere else, well, then that is a disconnect in the air barrier system that needs a lot of attention. So if you can go all the way around, similar to Gord's image earlier, that red line exercise is really important.
Yeah, so like and for us, that's why creating sort of like this monopoly frame, and if you kind of see, it's a simple shape, right? The only transition point that we kind of had was from at the foundation level, which we see this little detail on the right, where we are transitioning from an exterior barrier to an interior barrier. But making it simple is that's why we were able to achieve these great air tightness. And I think it was that, and also combined with belt and suspenders approach, right? uh, because we always and always all of our job sites we try to do at least a minimum of 2 air barriers, because I think it's always necessary to, if one fails, there's always another one, right? So we're trying to get always a better approach. If one is pierced, there's always another one there. So and even in this job site, we kind of had an unexpected third barrier because the inside wasn't supposed to necessarily be redone, but we had to take out ultimately the drywall, and we also did a sort of like a third air barrier from the inside. So redundancies maybe, but that's how you achieve great air tightness.
And let's see if I can get to the next slide. There we go. So here are some progress photos of the project from inside the basement and also on the outside. What was important?
We kind of have to turn our heads to see.
On the side a little bit. What's important here now, we had already done the first air tightness test before the framing went up, and there's a slightly better picture on the next slide.
Yeah.
But the important part of this process and these photos is to identify that Felipe was able to sequence the progress of construction such that he was able to do a mid-construction test as soon as the primary air barrier was complete, which included that white house wrap on the roof, the black house wrap on the walls, the window bucks with the windows in, and the basement insulation or the air barrier strategy completed. That allowed us to hit that 0.4 ACH mid-construction. And actually, we tried to do a pressurization test just to see if there was anything that would blow open in pressurization that may have sucked close in depressurization. But it really billowed out because we didn't have the framing on the top. And so we had to abort that in fear of perhaps introducing a few holes with a lot of staples getting popped off. But all that to say, sequencing is a big part of it. And from my perspective, oftentimes a bit of a struggle to get these early mid-construction tests completed with great results. And I believe I have one more photo, one more slide coming up, and that's this one, Felipe.
Absolutely. So you see like the amount of level of restructuring on the roof. I think the roof was one of the parts where it took definitely more time than expected. We had to restructure that roof not only to carry the new load of insulation that we were adding, but also the future solar panels. Maybe that approach could have on the next project, maybe considered an over truss might be a more fast approach. But I think it worked on this project. It worked really well, and but we did it during peak summer, so it was definitely hot for the guys working on the roof for like two weeks straight, restructuring and getting all that insulation in. I think also from that picture we see like the venting strategy for the roof, which is a standing seam metal roof. It really is only vented through the soffits and sort of like a mesh product there. So we're still getting some roof ventilation. We did, for example, change that attic that was kind of in the knee wall in there from a vented attic to an unvented attic. So that was something also that we did, which also permitted us to use the space behind the knee wall as sort of like ventilation chases. So for us, it really simplified and gave us extra space to the building. And yeah, window bucks also was a great addition. It was an easy way to make those old crooked windows, right, or old crooked openings, sort of like straight, new, and easy kind of to install and have the same details all around. And of course, that picture is not kind of complete, but we always use like double tapes to seal our windows on the inside and on the outside, and also an expanding foam. So we try not to use any spray foam there too. On the right, you also see sort of like the that picture was taken last week at the client's house with a 50% relative humidity, clean air, stable, constant temperature. So clients are very happy. It's a very comfortable house to live in. And maybe one thing that wasn't added there, we did use a heat pump hot water heater, which was the Sanden Sanko, which is a split unit. So there is an outdoor compressor. That's also one way where when we were looking at it with Stefan to kind of reach that net zero, we were seeing that the domestic hot water was a big element that we couldn't, that like when we're reducing and putting that much insulation, it takes a significant importance. So for us to really reach those levels that we wanted to, we had to address that domestic hot water.
Yeah, and I would say that my final point with this, certainly from an air tightness perspective, and this approach of the chainsaw retrofit and Larson Truss, not only was the air barrier detailing and implementation super successful, but I caution everyone to think that the depth and the inches of insulation that was required to do this is far more expensive than, let's say, 2 inches of foam or something like that, to use Gord's example. I encourage you to do the financial analysis on this, because 2-inch of something compared to an 8-inch Larson Truss with cellulose, which is a very affordable insulation material, you get more bang for your buck with an R30 exterior insulation than a little bit of insulation on the outside of the walls. Plus, you avoid that dew point and condensation risk of the that hard surface that Gord pointed out, and you keep that building nice and safe with air tightness and great insulation outboard of the condensing plane.
Yeah. For the basement, I think the air tightness strategy, we saw a picture, but the liquid applied air tightness also kind of helped us for those tricky spots. The product I think we used was one from Proclima. It was really good because on a rubble foundation, it's kind of hard to get a continuous air barrier. So something liquid applied was definitely easier for us to use.
Wonderful. Okay, thanks, Felipe. So I'm going to move on to Mark Tritton from the Lanark Design Build Group. With this 1912 brick farmhouse, which is all an interior renovation. And I'll allow Mark to describe the project and take it from here from now.
Yeah, so we ended up with this project, but we modified the plans because what we were presented with was a set of drawings that actually did something like Felipe did on his project, and it called for cutting off the eaves, chainsaw retrofit type approach, and a Larson truss on the exterior of this brick farmhouse. And the people were very sentimentally attached to the appearance of the brick and the heritage home and everything that went with it. And their inquiry was, can we not do something different? So part of what we did was an initial investigation of the house, cutting out some lath and plaster on the inside, confirming the type of construction we had. And that, I will say, for anybody who is renovating any older house, whether it's a 1990s house or a 1940s house or a 1912 house, is kind of critical. We need to understand what it is we're working with before we start to plan how we're going to do the air tightness or the insulation detailing. So in this house, for those of you who are familiar with that age of house, it's a balloon framed house. And we got lucky in a sense because it's a single course of brick on the outside. Inside of that framing is a board-on-board finish on the old stud wall with a small air gap. And for those of you who are familiar with masonry and how it behaves, what we certainly don't want to do is eliminate that air gap to allow for some drying potential of that masonry, because of course it's not waterproof. But now how we get an air tightness on the inside of that. And what we did was we approached it somewhat like Felipe said, with a liquid applied membrane. So we were talking to the owners and seeing how we go about detailing this house to achieve what they wanted to do the inside out, as opposed to an exterior approach, which was initially specified. And what you're looking at there is sort of the exterior of the house at the outset of the project. In the right-hand slide, you'll see a little note about an ICF detail, and that came up as a result of wanting to create drainage planes on the outside of the house in anticipation of then sealing on the inside. So improving waterproofing, which we knew wouldn't exist on that age foundation. But when we took it apart, that foundation was a nightmare. It was not in good shape. And even excavating was a little tenuous. So we came up with a detail to create an ICF wall on the outside of the existing foundation wall, tie it into the existing masonry, and bond that for a thickened foundation. So although we were here to do air tightness and super insulation and some other renovations, we ended up going down a bit of a different path to begin with. And that's why we need to understand the houses we're working on and take the time to investigate them before we start determining exactly how we're going to address things. Because as I'm sure Gord can tell you, and Stefan too, if you don't, you can create a lot more problems than you're solving. You can turn what appears to be an updated, modern version of your house into something that rots from the inside out. You know, we talked about that in the early days of our 2000 building when people weren't getting their materials right, or there was too much air leakage through the polyvapor barrier, and that wall didn't have any drying potential. That's a common mistake and one that we can't afford to make, especially with assemblies like this. So that's basically where we came at it, and we're approaching it from the inside. We also got lucky in that these clients were very open to that, and they live there. They don't have children. They're middle-aged, and they were willing to put up with a lot of mess on the inside of their house. You know, cordon off rooms and not have use of them for a week or two. Not a lot of clients are up for that. You know, with an occupied house, it becomes a challenge, but they were. And as this slide outlines, and I think Stefan can talk to, we had some specifications that worked pretty well. You know?
Yeah, and this is a prime example of how a project like this can develop a roadmap. So develop that end goal of where we want to get to, but then phase it throughout the process, depending on the situations and the variables that come into play, whether it's accessing grants and loans and being strategic about that, or accessing parts of the house so that the family can move around and still live within it and slowly work at it. So you can see here that the air tightness coming from about 10 ACH has already been cut in half to about 5.72 ACH, with more work to come that will hopefully see the final target of less than 1 ACH achieved. So we're looking forward to that. But it has allowed us to come in and test as we've gone and validate that the work that's been done along the way has been very effective. There are the other bits of information about the specs that have gone in. The cold climate air source heat pump has already been installed, but other things like the ERV and the hot water systems are part of the next phase of the process. And from, go ahead, Mark.
I'll just note there is a note on that slide that says the solar panels aren't in, but they actually have been installed. They're just not on the house because that house doesn't lend itself very well to it. They're on an adjacent barn roof. But the solar panels are up and running now.
That's right. And so right now, this is the results of the energy reduction, even at this phase of the process. So we still see a healthy 64% energy reduction without the additional PV generation. And what's interesting here is that the GHG reduction is higher, unlike Felipe's project, where it was all electric to begin with. This, I believe, correct me if I'm wrong, Mark, but I believe they were on propane or natural gas or oil or something like that. So now we have a greater GHG reduction compared to the energy reduction.
Yeah. So they've been removed from propane entirely. And their next stage, as Stefan pointed out, is it's staged. We like to call the next one stage 64, but it's not quite that bad. They'll be upgrading their HVAC a little bit more and adding in that ERV and also upgrading to an air source heat pump water heater. I don't think they've chosen the exact one yet, but we've been looking at a couple of different ones. And then the big one is the third floor of this old farmhouse. We've done the basement and we've done the main floor and the second floor. But what we're getting now is a lot of stack effect and a lot of leakage still on that third level, which we haven't addressed yet. So I would say that the majority of that remaining 5 ACH 50 tightening up will occur quite easily when we get to that attic stage. And you can see on the old square part, 4 square part of the house, what that attic looks like. And you can imagine how many little intricacies we have to deal with when we get up there. But that is on the agenda for this spring. You see in this slide another picture of that ICF detail on the outside, which worked quite nicely to address the foundation. Also gave us a surface that we could do proper water tightness and drainage on. And here are some slides akin to what Felipe was saying about different materials. And as we mentioned, it's important to understand the building type. In this case, we have a balloon framed house. So that stud in the left-hand side frame that you're seeing, those studs go from that third level all the way down to the basement. And in doing so, they provide us that 4-inch space uninterrupted all the way through. So there's no platform framing going on. There's no interruption. We talked about drawing. We can now apply that same liquid applied membrane on the old foundation wall on the inside, bring it up into the cavities, and then tie it into the spray-on version that we've done on the inside of the walls. We've then added rock wool mineral fiber insulation. And because we had the space and we wanted to boost our R value a little bit, we added another 1.5, 1 5/8 of EPS foam. This is an EPS graphite foam. It's got a foil face, but it's perforated. So it's meant to be used actually on the outside of buildings to allow for that drying potential. We repurposed it and used it inside. But we've also gone down that same road of redundancy that Felipe mentioned earlier, in that we have that foam over top of a VDR and a smart membrane behind it. So we've got 1, 2, 3 levels of air tightness addressed without causing any issues and allowing that brick on the outside to still have that drying potential. Attic space, we're going to do precisely what Gord alluded to earlier, and that is we've emptied out the attic space, get it down to the old lath and plaster, address any electrical, box over any light fixtures, new or old, and give that attic a nice clean layer of spray foam so that we've got not only insulation, but we've cut down on thermal bridging. And this is just a picture of one example of that. The one on the right is just an example showing the box. But in doing a renovation about a decade ago, we had some leftover foam. So we were talking earlier about coming up with strategies that work. This is one that works for us beautifully. It recycles foam that we're already using on site. And we can create boxes to house fans, electrical, whatever the case might be. In our particular case, if we're renovating and we're removing the ceilings, we also add foam on the ceiling, on the underside of that. And that's what you see on that far right slide, is the box tied into foam that's on the ceiling.
I really like this detail, Mark, because there's so many times where I've done a mid-construction test and the pot lights with the vapor boot that I used, it's really difficult to seal that up afterwards. So a nice, rigid, solid, airtight box like this, where you can control what goes in and out and seal it well, that's a great strategy.
And it's very simple to do, and it's something something you can get people to do while they're having lunch, or you can have an apprentice, a student, do those things. that comes back down to our air boss. We have to make sure that they're done right. But if you're doing those things, it's a matter of coming up with details and materials that work. Felipe and I both use some products from, the same supplier, the tapes and the Mento and the Intello. There are lots of other ones out there from different suppliers. Another liquid applied membrane that we don't have a lot of access to yet in Canada is called Passive Purple. Things like that. It's important to educate yourself about what's available in your area and make good use of those resources to achieve the type of results that we're getting. Gord also alluded to and mentioned the product Air Barrier, Air Seal. We've adopted that. I think we were some of the first people in Eastern Ontario to use it, including on a 200-year-old farmhouse. But you can see the certificate that you get on the right kind of indicates where you're at in the start, that size hole that Gord talked about, and where you end up in the end. We can't use that particular product in our farmhouse rental that we're talking about because it's occupied and because it's furnished. It simply wouldn't be practical. But in others, we certainly have. And this is going back to another slide that Gord showed. If your client is only doing, if that roadmap to net zero renos is going to be segmented a lot, and one of the first things a lot of people start with is a kitchen or bath reno, then for heaven's sakes, take that tub out, take that shower out. And maybe there's a way you can address that wall alone where you might do something a little different later on. But at this point, make sure that the wall behind that is addressed. Don't leave it. Think about it. Not sure how those slides got in there. That's a chainsaw retrofit, another job, but very similar to what Felipe was doing on his project.
Wow, and it's wonderful. I don't think I had a role in keeping this slide in, but it is another example of a very successful chainsaw retrofit with an exterior approach. Once again, going from about correct me if I'm wrong, Mark, about 9 ACH all the way down to a final test of 0.68 ACH.
Correct.
So a really great result. I believe you use wood fiberboard on this particular project on the outside of the wrap that we had here.
Yep. So the approaches have to differ based on what you're dealing with. And you don't always get dealt a nice set of cards. It's like a bad poker game. You can get a hand that you look at, and if you're in a poker game, you can withdraw, but you can't withdraw from most of your clients' jobs. They've hired you to achieve a result, and it behooves you to come up with a strategy that's not only effective, but reasonable in its approach and costing. And those are the balancing acts we have to do as renovators. But I think as long as we take the time to educate ourselves and find the right products, then we're in good shape. And maybe I'll just finish on that note of education, because we've been talking about air bosses, and we've taken a slightly different approach, although yes, I still maintain oversight. Every single one of our people is taken the Net Zero Renovators course, the Net Zero Builders course, the Advanced Science course, and a variety of others. And I would say to those of you who are out there listening who haven't done that yet, for heaven's sakes, take advantage of it. Even if you just start with the building science course, you'll have a great understanding of what it is we're talking about here and how to work your way into achieving those results. And if you partner then with someone like Stefan, an energy advisor, and you make that a firm partner in your business model, then you can't go wrong. Whenever you have a question that you might not be able to address, you can reach out and ask your EA. So we take great pride in the fact that our carpenters on site, even our apprentices, our student who's going to be working with us full-time next year, has just finished the advanced science course, and he'll be taking the net zero renovation course shortly. If all the people with boots on the ground have the same kind of understanding that we're talking about, you can't help but achieve good results.
100% agree. Nicely said, Mark.
Can I make 2 quick comments?
Sure.
I've heard chainsaw retrofit more times today than I have in the last 30 years, and which is great. And I don't know if folks know the history of that, but I'm pretty certain it was Rob Dumont who was one of the early researchers and early heroes at the University of Saskatchewan who came up with that concept and did his own house literally 45 years ago. So he's passed away, unfortunately now, but I was at his house years ago. I used to live out there for a short period of time. And Rob will be thankful for the fact that we are using that term of simplifying the renovation by not being stuck on the old, all the roofs there. I can't change that. Yeah, you can when we do it correctly. And I know it's not easy. Felipe, you were saying restructuring that roof. So thank you for both for resurrecting that word. And Lynn, it's going to be part of the strategy, right? I love what you said, Philippe. Not all houses will work, but this one was kind of all things came together. Let's not miss any opportunities. And Mark, I did correct the slide now, but I think your project, it said 1980 original build. It must have been 1880, given the
1912.
1912. Oh, we both numbers are up. Fair enough. For some reason, it said 1980. Maybe that was a previous renovation or something. So I'll correct that on the slides before we send that out.
Awesome.
Thanks for that. And thanks for the teams here, because part of what you were saying, Mark, also about the training, what we found is that we encourage your entire crew, your lead carpenters, your laborers, everybody to at least take the building science, because what we find, and I'm sure Felipe and Mark, you'll see on your sites, and same Stefan and Gord, is that when we understand why, when we understand the why behind why our work is important, why the craftsmanship and the attention to detail is important, it resonates. Did you find that with your teams, that as soon as they built up and they understood that they were contributing to this fantastic result, that helped on site?
Absolutely. We have a standing challenge with our team. Our best ever air tightness was 0.12, and that was a renovation.
Wow.
And so we literally went out for lunch after that and celebrated that result. We haven't managed to beat it yet, but we will. And the steak dinner stands as a reward for that. And that's just a little fun that we can have along the way. But in giving you an example of how, if everybody
How do I
believed
know?
on the
A lot of people,
ground
when they think of the phrase, how do I know? They always want to put the what behind it. How do I know what I'm supposed to do?
yeah. So
Right.
the thing there is that everybody on the team knows how to approach it and is invested in those solutions. So it's good.
Felipe, how did you find it on your team in terms of that connection to, oh, this is the impact I'm having?
Well, I think the leakage area also is a good visual for sure. Then I mean, I think we worked with some sub trades that it was their first time really kind of like measuring it. I mean, in our case, it wasn't that complicated. It's like, no, we were not asking them to kind of bend over backwards to kind of go try to tape a tricky place, right? They're a team of carpenters that are just doing nice work, right? And if your details are easy enough, it's not that much complicated to do nice works with good product, right? So I think it's using the right products makes it easy to work on those areas. So nobody complains about it, and they just want to do good work, just how they want to frame up a wall that is straight. They want to contribute to the air barrier, but then sometimes they can't really see it. So kind of having thermal imaging, blower doors, constant blower doors, and having sort of like that like I said, the leakage area kind of puts it into their perspective, and then they're able to become better, right?
Yep.
All right, we're going to dig into some of the questions that have come from the group. So the first one, Gary was asking on Felipe, on your project, in terms of the heat pump system with supplemental heating, was that involved? Was there electric resistance? And what was that system? Was it strip heating in a central space, or was it baseboard heaters?
No, electric resistance.
Electric resistance.
Which is very, very rarely used.
Okay, in terms of, and part of that is also there's that point on designing your system in terms of making sure the cost effectiveness of when that backup heat comes on and managing all of that. Was that a struggle? Is that something that you were able to tap into, Stefan, for in terms of navigating what size of resistance?
Well, yeah, of course, we definitely needed to do that F280 calculation, I think, and we worked along, and also our mechanical contractor was involved since the beginning, so we were managing the right expectations, choosing the right systems for it, and yeah, that's how we went to choose. We had just that resistance. Really, it's a backup, right? We mostly don't use it, and the client sees on his energy monitoring, he can definitely see that it's not being used all the time.
Excellent. One of the points that you mentioned about bringing the mechanical in, one of the terms that I hope we get to use a lot during these webinars is the integrated design process, which is bringing in those that have the right answer, bringing them in early at the right time to get the right information to make the right informed choices. So that's part of the process. The other part on all of these projects, we mandated that each project had to have a qualified net zero energy advisor. And we're going to be giving resources at the end of how to find, you know, Mark and Felipe and Stefan, but also other resources that contribute to the success of your projects. But a key part of that is that teamwork and bringing those people in. So I've got a question from Matthew for the Lanark project. The interior insulation and brick houses and the trickiness around that, especially if the brick is relying on the heat from the walls for drying out. How did you navigate that? Because that comes up on quite a number of our projects that have brick.
Yeah. So there's only so much you can do with that, but the biggest issue with the brick, and we consulted with a heritage mason about this as well, so some of that integrated design process is ensuring that the brick is in good shape and doing the necessary repairs to that, but also ensuring that it has that air gap behind it. So often what we see is people insulating up tight to that brick and not allowing that moisture management. We also installed weeper holes in the old brick wall at the base, which you don't normally get, of course, in old masonry. But we understood that there would be some condensation occurring on the back of that wall, and it needed a place to go. So we actually had weeper holes installed along the bottom course of that masonry. The other important thing that we got lucky with it, was that we had a surface that we could work with for an liquid applied air barrier, which gave us the opportunity to do that continuity with the balloon framing from top to bottom. So far so good. I think all the people that weighed in on it agreed that that was a reasonable approach. It would not, in my opinion, have been a reasonable approach, for example, to spray foam the backside of that brick. But that's a whole other debate for masonry
Over to
maintenance.
Gord there, yeah.
If I may, Chris Timisk at George Brown College did some pretty good study on that. You could look up his work. Joe Stiebrick at buildingscience.com. If you don't subscribe to Joe's stuff, he's got some great articles on mass walls and how to do them. And you have the right idea, Mark, is creating that airspace, and whether you do that with an existing airspace or you create it with, say, a dimple drainage to allow that air / liquid water. So there's been work done on that, and I like your idea. Consult a masonry specialist.
Yeah, we're very fortunate in the Perth and Lanark area to have a lot of excellent heritage masons.
Yeah, definitely a lot in that area. And we also had one project from the Guelph area, a 200-year-old farm home, and definitely had to do that hydrothermal investigation on that to make sure that the measures that were being done, to your point, Mark, weren't going to cause other things. It's the if this, then what, right? That is a constant balance. For the Larson Trust, and we've often heard with the Larson Trust, just turn it on its side, apply it to the roof. Was that a thought in terms of applying the Larson Trust system for roof applications? Felipe, you had mentioned that you might go to a scissor truss type formation, but that's sort of boxing out.
Yeah, I think it all depends. Well, it depends also on the engineer on the file. You know, when you're doing, I mean, that's also one of the points that was kind of like was a bit hard to navigate is that, I mean, Larson trusses are not seen every day. So the engineer on the file was sometimes a bit wary of it, right? So for the roof, he was definitely a bit more, well, he was happier with an I-joist approach, which is sort of like a similar Larson truss approach. I mean, it's just more, more wood, but we decided to go with just an I-joist approach. We didn't do like a conventional Larson truss there.
So I think that part of it is in terms of also what we've talked about in the past is part of the measures of what works on site is what is available in terms of your trades, your, all of your contractors and what is also most familiar. And that was part of, Stefan, you can speak to this in terms of part of what you mentioned about the cost effectiveness of Larson Trust. I know hearing from some of the teams, it was also because it was standard construction. It wasn't something new, it was something familiar, and that helped in terms of the cost effectiveness outside of that specific line item of cellulose versus other materials. Have you heard that on other projects as well? And same with our Felipe and Mark?
Yeah, that's right. And this one was made even more easier of a decision to be made because of that proud foundation, and that essentially it's just a double wall stud with no sheathing on the outside because that wasn't required. So the details surrounding it and the implementation, it's just building another wall and tying it to the existing wall after the air barrier is complete.
We had ran we had done like the analysis of what insulation to use to kind of get those levels. We had considered stone, rock wool and the comfort board one, like the continuous insulation at the end on the exterior. We had considered, I think, foam too, but in the end, for the building that we wanted and the levels that we wanted, cellulose was by far the best bang for buck that we could have gotten there.
And I know
Yeah,
Enercan has that cost benefit analysis tool that also digs into some of that, right?
cost benefit analysis tool, but also we use the MCE squared tool to do the embodied carbon calculation for this. And you could see that in one of the slides where essentially it was carbon neutral to add in all of this additional new material because of that carbon sequestering side of things. If we had gone with, and we did an analysis of this and compared it if, like Felipe said, if it was all rock wool or all spray foam or all whatever to achieve the same effective R value, then this one was below the line as opposed to everything else being above the line with respect to upfront carbon.
And that's the material carbon emissions estimator from Natural Resources Canada. Yeah. So they build a lot of these foundational tools that our industry then leverages and puts into the system of how we go about these projects and balancing all of that. There's been a few questions and a few mentions about radon, and I want to tap into that in terms of Mark and Felipe, whether that was something that had been of concern in that area, but that is something that, Gord, I'd like to hear your thoughts on that as well, in terms of that navigating. But we'll start off with Mark in terms of whether that was something that was on your project.
Yep, it's on the radar on all of our projects, and what we've done in that particular farmhouse is we have a radon measuring device installed there, and we've been taking readings. As Stefan will be aware, the homeowner at that particular house is kind of a computer geek, and he has his entire house fully wired with monitors of all kinds. In fact, he had it monitored from well before we started. So this makes an almost perfect case for following how the house develops over time. Radon levels at this point haven't been significant. On another one, in fact, the one where we saw the chainsaw retrofit with the blue membrane on the roof, that was an issue. And subsequent to that house being finished, we brought in a radon mitigation team, and they installed devices and venting to correct it, and it fell to well within acceptable limits. On any build where we're fully taking up the basement floor, we put in radon mitigation from the outset. So a specialized foam layer with continuous venting, a passive vent, adjacent power if we ever need to put in a fan, and venting to the roof. So it's something we incorporate in all our builds now.
Us, in our case, and for that project, we had measured, but radon wasn't a concern, and thank God, because it was, I mean, the basement is basically a crawl space. It was a 6'2" clearance crawl space, so we couldn't really get any insulation either below the slab or above the slab, or any air barrier too. Would have been too complicated to go and put new finishings on it. So we didn't want to kind of touch the existing slab there. But in that area, there was no considerable radon levels.
And I think, Lynn, you would support the test radon before,
Mhm.
and generally speaking, air tightness and adding ventilation improves radon, but you should test after.
Yes.
Radon's that important, right? That you, even if you didn't put in a strategy, do put in a strategy, as Mark said, when it's easy to do while we're there, do it, but always test before, test after. In general, air tightness and ventilation that you would do as part of net zero reno would reduce the opportunity for radon.
Exactly. And I'll put in a plug for radon testing because we are heading into November. It is the ideal winter heating time for a 90-day radon test. But it's the information, and you've all spoken to this. You cannot address what you don't know exists or you haven't measured. Radon is one of those indoor air quality contaminants that we cannot sense. We cannot smell. It's not a mustiness. There is nothing there that we can sense on our own. So this is why it's really key to test, but before and after. And the reason why we really emphasize testing before is because with all of these projects, when we look for, and it was in our title of our initiative, cost-effective approaches, there are times and windows, and Mark, when you mentioned, you're doing a kitchen renovation, that's the time to take the drywall off, see what's happening behind the wall. So all of these different interventions and work that you're doing on your house, it is really helpful to have that engagement with your renovator who's qualified and trained and educated enough to go, this is the opportunity. This is going to be the most cost-effective time in the next 10, 15, 20, sometimes with kitchen renos, 30 years for us to address this, because we're not going to be coming at it in any other way. So that's a big part of what also is coming out of the finding, is tap into where the work is already planned, is already going to happen. Major renovations are happening all the time. You saw the 108 billion that Canadians are investing. So that's also a key aspect of making sure that's cost effective, but you have to bring that to the table. We will be getting into some of those resources on how to get that training and how to access some of those. There was an earlier question also about studies about the improved air quality, like air tightness and improved air quality on health impacts. And I know, Gord, there is a lot of documentation on the negative impacts of mold and poor indoor air quality. So we'll do a little bit of a deep dive, and some of the questions that we don't get to, we'll try and answer them as we wrap up and send the information out. We're going to close off on one question here for everybody, is that interested in strategies to improve air tightness of residential buildings. I've heard from some energy advisors that air sealing is rarely pursued as a standalone upgrade, as it's often considered not cost effective on its own. So asking for insights on that. And I'm going to add a little bit also about, Gord, to your comment about when we used to open up windows, and that was our primary source of ventilation. A lot of that also, even when we do have cross-ventilated windows, we don't always want to have them in Edmonton or Winnipeg or even Ottawa in the middle of winter to be able to freshen out the house. So it's being able to have access to fresh air regardless of outdoor conditions. And we keep hearing about that for wildfires as well. But in terms of the insights of balancing that conversation between air tightness and cost effectiveness, you've spoken quite a bit to it. But what are your general insights in terms of, we'll start off with Felipe and Mark, and then Gord will finish off with you and Stefan, in terms of where air tightness sits on the hierarchy of must-dos?
Well, I'll start, having spoken to many clients over the years. because I started out building R2000 houses, it's sometimes a difficult sell. As we know, clients are often engaged and involved in what they can see, and they typically can't see airtightness. They can feel it, it affects them. It's ultimately a critical part of their home comfort, but you have to educate them more often than not as to how important that is and make it a priority. It seldom comes as a list that people are talking about. If it does, it's in a very minor sense, and they say, "Oh, I've got a leak around my window, and I want you to spray foam that." And that can start the conversation, but the conversation needs to delve a little further in. And like you were talking about with kitchen or bath renovations, or Gord mentioned, there could be isolated incidences where you can bring that into play and improve it. Maybe you're not addressing the whole house, but as you move through a sequence of renovations, then you've got the opportunity to continue that work.
Felipe, how do you find that conversation goes with your clients?
Well, I try to have them I try to have them deal with air barrier as sort of like the most important at the top of the energy efficiency ladder. That's where I try to put at least as information out there. I mean, I'll go to basically all the points that Gord mentioned at the beginning, and that just by itself is sort of at the end of that discussion, the clients are pretty much sold, right? But I try to encourage always air barrier approaches to try to do them. Yes, you can do them by parts, but I try to do it as a whole step. I think that's how you get a most effective air barrier. So we try to deal as sort of like if we're trying to phase out the job, air tightness is one step of the job. So I feel like it's not the case for every house, especially if you have an interior approach or an exterior approach. But that's how usually I address the conversation. And usually it always leans to if the clients are, if we take Gord's presentation and we kind of give that to the clients, like most 99% of the case, they'll understand and see the value in air tightness, right?
And Stefan, I know you and your team celebrate the air change achievements of your the various projects that you're working on. When you see that, do you find that the homeowners and the clients are involved in that celebration?
100%, yeah. I mean, I think that the most anxious in the room while in our test is the client, right? And it's sort of like it's a double-edged sword where you kind of now you bring on the client, so you really can't miss your air test now, right? So so you really have to, the pressure is really on. But I think that once they understand it, they're really rooting for it.
Yeah, and we would like to have more net zero projects or net zero reno projects in our Tight Building Post series. But what from our perspective as energy advisors, when we do a pre-retrofit assessment, it's always great to walk around with the homeowner. If the conditions are right, we show the infrared camera more to easily identify and visualize the air leaks. And then we go further and actually feel the air leaks if it's possible. So that visualization and going around and actually touching and feeling and seeing the air leaks makes the homeowners more aware of the impact that they have. And then we show the results of it in the energy modeling and analysis process. And then we always encourage them that they or their renovator or their team, someone who is the air boss, perhaps do some air leakage, blower door assisted air leakage detection and air sealing, where you're actually depressurizing or pressurizing some of the strategies that Gord had mentioned in his slides, and where you can actually feel the air leak. That's what you need to tackle, because oftentimes people will spend a lot of time and effort and caulk and other products to do work, and it might all be for naught when we come back and do the final test because they haven't actually addressed the air leaks. So that's an important part for those in the industry and going through the process, whether it's the homeowner or the renovator.
Lower door directed air sealing. I always use the blower door, and that has been shown to be cost effective. That said, I'm going to give you the bad news and then the good news. The bad news is none of this stuff is cost effective. None of these retrofits are actually a good investment in, depending on who what bank you want to use or what mortgage calculator. The good news is there's $108 billion worth of renovation work done without any cost effectiveness at all. It turns out we're trying to sell this stuff the wrong way. We're trying to sell it on energy efficiency payback. It's not about that. It's about all of the other benefits. And
What
I'll
it
give you
does.
I tell this story all the time. My brother's tired of hearing it. My brother's house, 26 air changes per hour at 50 pascals. He couldn't figure it out. He's spending $5,000 a year in heating, was not motivated to do anything. I finally said, Jim, if I did the equivalent leakage area, I took all the holes on your house, it'd be the size of an open door. And immediately said to me, do you think that's where the mice are coming in? And the next day, contracted for $4,000 worth of air sealing. And that was cost effective for him. That
Right.
was what sold this. So focus on, if you're in the sales world, I've been doing this a long time and spent the first 30 years of my career trying to sell it on energy savings, and I've stopped. And energy savings is a lovely bonus, but it's not the reason why people do $108 billion worth of renovation work. We can be really successful. I love all the hints. Do a blow door test, show them what is being wasted, show them where the wasps, the bugs, the dust, the noise, show them that. And then that will get them to do blower door directed air sealing.
Exactly. Now, you should be seeing the survey that's up there. I'm going to give a couple of resources, but Gord, to your point, this is what we've been finding through our project, that delivering on the homeowner wants, this is the process of getting there. And those wants are a lot of them, those non-energy drivers. So if I can just get a flag of whether the survey is up on the screen.
There's a QR code, yes.
Okay, great. Great. So we're going to get everybody to give us some feedback on that. I'm just going to leave it up for a couple more moments because I do want to get to some of our resource slides. We are at time, but we're just going to hold you for 2 more minutes. And we're just going to grab that. If you take a photo of that, and it'll also be in the deck. But if you can do that survey right away while it's all fresh. The other QR code that you can grab as well, but again, this will be is sign up for all 5, build up your teams, bring them along, have everybody on the same page. That's been critical from our engagements with the municipalities all the way to tools on the trades on the tools, is everybody on the same page in terms of what you're trying to achieve. And the other part of what we'll be sending to you is part of the resources. There are a lot of resources out there. Our Renovator Manual starts with your best practices in building science. Renomark is a distinction of leveling up, and all of our net zero renovators are Renomark. Who to work with when you're looking for a qualified professional to work with. And then also there was a question about the training. We do have offers currently available for rebates on some of our online training. So this will be going out with our deck, and we'll just go back for those that weren't able to grab that survey, and we will wrap it up. And Gord, Mark, Felipe, and Stefan, I want to thank you so much. And for Toby and Kimberly and Lori and Brendan, all behind the scenes, thank you very much for today's webinar. Have a great day.
Great job, Lynn.
Thanks, everyone.
Thanks.